Ellipses. A quick Google search will show us that we have lots of different shapes that we can begin to define some things. But let's look at some images like this one right here. If I have this image right here and I take a look at this, I can see the conic section slice that's going to create an ellipse. We've seen that as the objects that we passed around in class, but just kind of a diagonal slice through a cone is going to create this object that we call an ellipse. So let's start with a definition, and then we're going to get the formula for it. An ellipse is all points whose sum of distance, and we'll explain what that means here in a bit, the sum of distance to two foci is constant. This is a definition you're going to have to know and be able to understand. So that starts with memorizing the definition. But let me kind of start with a basic here. Let's draw an axis. I'm going to draw a fairly big axis. And at 0, 0, I'm going to put a center. And at that center point, we'll label that with a little hk, because that's what we're used to. And instead of having just one center, we're going to create two different points. And we're going to call these foci, each focus. And there are two foci. So let me kind of do this one. I'm going to put one here and one on the opposite side. And we're going to label those with a capital F, just to represent that those are foci. And I'm going to draw the distance between the center and the foci, the C. So as we start to build these parts, we've already put some stuff down. So F stands for foci, meaning multiple of focus, plural. And foci themselves are equidistant from the center, which I'm going to denote with HK. And then we have a little c, and c is going to be equal to the distance from the center to the focus, or to each foci. So this kind of builds up what's going to be the creation of our shape. The next thing we need is a distance, and I need some sort of distance because this says all the points whose sum of distance to two foci is constant. Well, if I put a point kind of maybe up here, and I'm going to want a different color for this. Let's do a darker green. Put a point up here, and I draw a diagonal line connecting that to the focus, and then this one to the other focus. Basically, I'm going to create a distance, and we're going to call this point, let's call this point an M, because this is actually going to be what we call a minor vertex. So I'm going to call this point an M. So I've got kind of a little triangle thing going on here, and I don't want to confuse you too much, so we're going to break this up. I'm going to break this line up just a little bit, and we're going to do a dotted line here to denote a distance, and I'm going to do a dotted line here too. So I'm going to call this little distance A, and this little distance A. And we're not going to quite define it just yet, but I'm going to leave this as sort of an arbitrary thing. And then I'm also going to create this distance B that I'm going to define right now. B is the distance from the center to the minor vertex. And then we're going to say capital M is a minor vertex. So stay with me here for a second. This M is the same distance from each foci, and my 2A is the sum of the distances to the foci. Well, an interesting thing happens, and I'm going to kind of show this to you here in a second. I'm going to show you a quick YouTube video here, so bear with me for a second. That's the minor vertex. He's actually putting his pencil on, or his marker, and continue. Sorry, I should have muted that before. Okay, he's done. That's the idea. So I'm going to go back to this this thing, and we're going to try that ourselves in a sense. Obviously, I'm going to have a second M point down here that I can label, and then I'm also going to have two major vertices, one here and one here. And if I look at this, and I'm going to actually sketch this in a second graph here in a second, but this distance is also going to be A. So I'm actually going to define A right now as the distance from the center to the major vertex. And we're going to use capital V to indicate major vertex. I'm going to recreate this figure here in a second, but let me connect and show you what this ellipse would look like if I did sketch it all the way around. So let's kind of go down here and recreate this one more time, a little bit cleaner now that we're not setting up all the different parts. So draw a grid and label a center. And let's go 3 units to the right and label a focus, 3 units to the left and label another focus. And we're going to go 4 units up and label an M, and 4 units down and label an M. 4 units to the right, or sorry, 5 units to the right and label a V, 5 units to the left and label a V. And if I kind of look up, I'm going to see that, or sorry, look at my different distances. This is a little c, so don't confuse that with big C. This right here is a little b, and this distance is a little a. Well, we had one more distance that was also a little a. This distance here from M to F was also a. And this creates a very, very important relationship between these three, that a squared is equal to b squared plus c squared. Remember that a is defined as the distance from the center to the vertex, b is defined as the distance from the center to the minor vertex, and c is defined as the distance from the center to the foci. And so if you know 2 of them, you can always get the third one. And if you look at the way that we've drawn this out, we've made it so that a here was actually equal to 5, b was equal to 4, and c was equal to 3. And in fact, 3 squared plus 4 squared is equal to 5 squared. So what does this mean for us? Well, there's a very, very long derivation that I'm probably going to create a separate video for. I was thinking of doing it here, but just creating separately would help. That gives us the equation for an ellipse. And a general horizontal ellipse is this. It starts with the same x minus h squared plus y minus k squared, but instead of equal r squared, we just say equals 1, because what we've actually done is we create 2 different radii. I'm going to put a squared under x and b squared under y, and what denotes the difference between a and b is that a is bigger than b. A is the bigger one. We just call a the bigger one and b the smaller one. So if I want to make a vertical one, and let me kind of just do an example really quick of a vertical one. I'm going to do another one. Let's put a center here. Let's still go 5 up and 5 down, because that's an easy one to make mathematically correct. I'm going to change the foci though. I'm going to bring them out more. I'm going to make them 4 units out. That means that the b has to be 3 units, or sorry, the m's have to be 3 units. And I'm going to draw this ellipse like this. It's a little bit skinnier. As the foci move out, it starts to get skinnier. And the equation for this one, this general one, would be x minus h squared over b squared plus y minus k squared over a squared is equal to 1. Now, I'm going to reiterate these back on the general, or on the next page, so stay with me here as we move over to examples. The different questions here are going to help guide us through what we need and what we want for these. So the graphing form of the equation, we're going to pick between one of 2 things. So again, for vertical, sorry, let's start with horizontal. For horizontal, it's going to be x minus h squared over a squared plus y minus k squared over b squared is equal to 1. And then for vertical, it's going to be the same thing, just switch your a and your b. And the next thing is going to be to switch that. So that should work. The relationship between A, B, and C is also important here. This is going to be one that you have to memorize too. And this works because, again, you need to remember this triangle that A, B, and C on that graph, or on the previous page, A is always the bigger one. So if I look at the first equation, it wants the graphing form, and that one's given. So really what I need to do is I need to decide which one's A and which one's B. Well, this one right here is B squared because it's smaller, and this one is A squared. So since the bigger number, I'm going to say the bigger number is under Y, and Y is vertical, this is going to be a vertical one. And it's going to match the second form that we did, where the bigger number is under the vertical one. So what that means is that the center here is 0, 0, because it's x minus 0 squared, y minus 0 squared. And what I typically do is, after I've listed these three things out, I start kind of putting a little break bar, and I'd show some work before I move on to D, E, and F. I want to show the calculation of what C is. Basically, I want to show A squared is equal to B squared plus C squared, and find what C is. So A squared was 64, B squared was 9, and I don't know what C squared is, but if I subtract 9, I get C squared is equal to 55. And I get C is equal to the square root of 55, which is about 7.4. Going here on the graph, I'm going to put an ordered pair at 0, 0. And then I know that my A value, and I should list that here, A is equal to 8 and B is equal to 3. Since A is 8 and it's a vertical one, I'm going to go up 8. Not right 8, but I'm just going to go up 8 on the vertical direction, following the Y, because the big number was under the Y. Then I'm going to go left 3 and right 3 from the center. And these are my V's, and these are my M's. And my C tells me where the foci are. So I'm going to go up 7.4, which is just right about here and here. Kind of hard if you put big marks, but I'm just going to stick them there. Foci, or focus, focus. Then I'm going to go back and continue where I left off. So D, the foci coordinates, those are 0 and up radical 55 and down radical 55. So I'm going to put 0 plus or minus radical 55. So it wants the exact and the approximate, so I'm going to put also 0 plus or minus 7.4. The length of the major and minor axis, well, the major axis length, that is 2a. It's twice the distance of a. So I want to take the 64, take a square root, and then multiply it by 2. So that's 2 times 8, which is 16. And then the minor axis length is the shorter of the two. That is 2b, which is 2 times 3, or 9. Finally, we're going to graph it, and I'm just going to already graph the key features, so I'm just going to do a sketch here. And I tend to draw it in 4 separate arcs as best I can. Okay, that was okay. And that's it. Let's move on to the second one. Here, my graphing form is also given. It is a horizontal because my larger number is under the x, and the center is again at 0, 0. So I'm going to do the little break thing over here and say that I know A is equal to 4 and B is equal to 2. So C is equal to the square root of 16 plus 4, which is the square root of 20, or 2 radical 5. If I do a calculation on the square root of 20, I get out of the way, 4.5 or so. So I'm going to say it's about 4.5. Let's put the little break line down again. I'm going to plot what I know, center at 0, 0. And this time I'm going right 4 and left 4. And then I'm going to go up 2 and down 2. And I'm going to label these V's here and label these M's. Then I'm going to go right 4.5. Oops, that's not right. My C was too big. My C would fall outside, so I didn't do that one right. And I'm going to leave it and not try to delete that, because I show if that's what happens, then I actually should have done A squared is equal to B squared plus C squared. Easy to do if we get the Pythagorean theorem kind of all in our heads as being C is equal to, but it was always just the biggest one. So I go A is equal to let's see, a squared was 16 is equal to b squared is 4 plus c squared. So c is actually equal to the square root of 12, which is 2 times the square root of 3. And if I go back to here and actually do the square root of 12, I get 3.5, and that makes better sense. I go right 3.5 and put a little mark, left 3.5, put a little mark, focus, and then draw it. I could draw it right now, or I could wait till later. Let's go back and answer the questions. It wants to know the coordinates of the foci. That would be, well, this line there along the x-axis, so plus or minus 12. Oops, let's keep that as simplified radical. Plus or minus 2 radical 3, 0. Or if I put it in approximation, plus or minus 3.5, 0. Length of the major axis, that's 2a. So a is 4. That would be 8. And minor axis length is 4. Let's go to the next one. We have our first off-center one, still in graphing form. So I'm going to say that this is a vertical because my larger number is under the y. Center is going to be at -3, -1. Let's go ahead and plot that. And as I kind of do some work over here, I know that a is equal to 3, b is equal to 4, and if I do a squared is equal to b squared plus c squared, see, I'm going to write it this time so I don't make a mistake. 9 is equal to 4 plus c squared, or c squared is equal to 5. C is equal to the square root of 5, which is about, keep hitting the wrong one, 2.23, or just we'll say 2.2. So coming back, I want to put the foci down as up 2.2 and down 2.2. But let's put the other points first. Let's go up 3 for the up 3 for the major vertex, down 3. Oh, and I made another mistake. This b value should be that should be 2. I was correct there, but that should be 2. So I'm going to go right 2, left 2, because b is the square root of b squared. And then for my foci, I'm going to want to go up 2.2 and down 2.2. So really what I need to do is I need to say that my foci, well, I'm changing, if I look at this, this is the point -3, -1, and I'm going down and up from there, which is changing its y value. And it's changing it by 2.2. So I'm going to go -3 and then -1 plus or minus that c value. And that gives me the two ordered pairs in simplified radical form. Or, if I do it in real, I'm going to go -1 plus or minus 2.2. But I can actually put 2 points for that. -1 plus 2.2 is 1.2. And -1 minus 2.2 is -3.2. Major axis is 2 times a, so 6. Minor axis is 2 times b, or 4. And then I can just sketch and draw this. Make sure I've labeled things V, V, M, M, and F, and F. Okay, let's go down to the next one. This one's not in graphing form, but a very simple thing I can do is just divide both sides by 144. And so I get my graphing form of x squared over 9 divided by 144 is, I know this, 16. And then plus y squared over 36 is equal to 1. So that's the graphing form. It is a vertical because the bigger number is under the y. I know its center is at 0, 0, so it's going to make it a little bit easier. Let's put a center at 0, 0. I know that a is equal to 6, b is equal to 4, and the square root of 36 minus 16 is equal to the square root of 20, which is 2 root 5, which we just did a little bit ago as 4.5. So I want to go up 6 and put a point, down 6 and put a point, right 4 and put a point, left 4 and put a point, then up 4.5 and put a focus, and down 4.5 and put a focus. V, V, M, oh, other way around. V, V, M, M, F, and F. Then we come back. My coordinates of the foci are 0 plus or minus 2 root 5, or 0 plus or minus 4.5. For part E, my major axis length is 2 times A, or 12, and my minor axis length is 2 times B, or 8. Just to indicate, that's how long it is from here to here. That is 12 units apart, and then this is 8 units apart. So that's why you're kind of doing that. And lastly, just do a sketch of what this is going to look like. And let's move on to the next one. This one's not quite in graphing form. Looks like it is, but it's almost. I'm going to have to rewrite this as x squared over 25 plus y squared over 4, but now that 9, we're going to have to put that in the denominator of the denominator. That is actually the same as over 4 ninths equals 1. So that might get a little tricky, but I know it's still it's a horizontal, and I know my center's at 0, 0, so at least we got that going for us. Put a center at 0, 0. Let's see, A is equal to 5, B is now equal to 2/3, and I can't really rescale this that well, so we'll just do the best we can with a 2/3 B. If I do subtraction, and I say the square root of 25 minus 4 ninths. Let's see. 25 minus 4 ninths. Let's just cheat. And if I do a radical of that, boom. Yep, calculator will let me do that, and then I'll get an approximation of that. Almost 5.0, but 4.96. So this ends up being, C is radical 221 over 3, or approximately 4.6, or 4.9, what was it? Sorry, 4.96. Coming back, it's going to be a very, very tight one. It's just going to be very, almost impossible. You know what, we're going to rescale. Let's rescale by 2's. That's going to make this a little bit easier. Rescale by 2's. Basically, that means that I'm just going to put major tick marks here for the 2's, but okay. So everything's going to be double what it is in the graph. So when I go and put my A's into the horizontal one, I'm going to go right 10 instead of 5. Then I'm going to go up instead of 2/3, I'm going to go up 4/3. That's 1 and 1/3. So that's going to be in here and here. And then 4.96, that is ridiculously close to 5. Let's just get it close enough, and we'll call it, F and F. I put 2 vertical lines there because I'm just trying to make it really skinny. V and V and M and M. Strictly speaking, I could actually connect this now. You see it's a very, 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 very narrow one. That's why I wanted to double it, at least to get some effort of putting that in there. But my foci have coordinates of plus or minus root 221 over 3, comma 0, or plus or minus 4.96, comma 0. Major axis length is 10, and minor axis length is 4/3. And that's it. Number 6, looks like we need to complete some squares here, so let's do that. I'm going to go x squared plus 6x plus a box, plus factor out the 25, y squared minus 4y. Let's move this down here. Plus a hexagon, and then equals negative 9 plus that box, and then plus 25 times that hexagon, because I did factor out a 25. So keeping that all straight, I got 9 and 4 and 9 and 4, and that's going to give me x plus 3 squared plus 25 y minus 2 squared equals 100. Divide both sides by 100, and I get x plus 3 squared over 100 plus y minus 2 squared over 4 is equal to 1. And let's see, so that's my graphing form. It's going to be a horizontal, and then that center is going to be at negative 3, 2. If I do a little sidebar here and say that A is equal to 10 and B is equal to 4, or 2, sorry, then C is going to be equal to the square root of 100 minus 4, which is 96, square root of 96. 96 is 16 times 6, so that is 4 root 6. If I just do a calculation of the square root of 96, get 9.8. So this is also going to be a very tight one, and one of the problems of this is that my center is at negative 3, 2 right here, and I'm going to be 10 to the left, so I'm going to be off the grid. So actually I'm going to rescale this now by halves. So I'm just going to put a little note here, rescale by half. So instead of negative 3, 2, I'm going to go negative 1.51, and I'm going to put a point there. And then instead of 10 to the left and 10 to the right, I'm going to go 5 to the left, 1, 2, 3, 4, 5, and 5 to the right, 1, 2, 3, 4, 5, and then 1 up and 1 down instead of 2 up and 2 down because I rescaled by halves. It's going to make my focus really, really, really tight, so I'm just going to put a little tick mark very close to the vertex for the foci. I'm not even going to really label these. Well, okay, I'll label them really tiny. And that's the best I can do with that one. At least it's on the graph. And again, this is rescaled by halves. You'd have bigger graph paper so you can rescale however you want, or not rescale, you can just scale it up. So my coordinates of the foci, this is going to get a little tricky. It changes the x, negative 3 plus or minus 4 root 6, comma 0. Or not comma 0, sorry, comma 2. Or, then I'm going to do negative 3 plus or minus 9.8, comma 2, which leads me to the 2 points of 6.82 and negative 12.82. Length of the major vertex is 20, and minor vertex, or minor axis, sorry, is 4. Okay, next one, last one. Let's complete the square on this. Factor a 9 out of the x. So I got x squared plus 4x plus a box. Then plus 4 y squared minus 2y plus hexagon. That's equal to negative 4 plus 9 times a box. Then plus 4 times the hexagon. And that should be a 4 and a 1. And that should be 4 and 1. So simplify this. 9x plus 2 squared plus 4 y minus 1 squared is equal to, that's going to be 36. And divide, and I'm going to get the graphing form of x plus 2 squared over 4 plus y minus 1 squared over 9 is equal to 1. That is vertical, with the center at negative 2, 1. Do a little sidebar here. A is equal to 3, B is equal to 2, C is equal to the square root of 9 minus 4, or the square root of 5, which according to the calculator is approximately 2 point something. Oops. Sorry, one more time. 2.2. I feel like we did that before. Okay, so plot the negative 2, 1, keep it the same scale. 3 up, 3 down, because it's vertical. 2 left, 2 right. 2.2 up, 2.2 down. V, V, M, M, F, F, and connect. And the graph part's done. Let's just finish up the other little details. Foci are at negative 2 and then 1 plus or minus root 5, because it's y that's shifted now, or negative 2, 1 plus or minus 2.2, which simplifies down to negative 2, and then 3.2, or negative 2, 1 minus 2.2 is negative 1.2, and that matches where the foci are on the graph. Finally, major vertex length is 2, or major axis and minor axis length is 4. And that's it.